Hey everybody, here's the next tutorial in which we're going to look into using some randomness and look into sending different information to each instance within a poly. So let's make a new project. We'll call it John J. And always put your name in your project name. I'm going to call this tutorial 3_2 because I already built this and I'm going to build it again for you in the tutorial. I'll make a new file inside my project folder. And this one doesn't need to have my name in it because the whole folder has my name in it, so it's already identified as being part of John J, tutorial 3_2. But you can call it something like main if you want to differentiate it from your poly files. And then since I already have a poly that has everything I need in it, I can add an existing file, find that in a previous project. I can take it from tutorial 2, for instance, in my patchers folder, and it's called my_poly.maxpat. I open that and it's added to my project, and as we've talked about, you then need to consolidate if you want a copy of this file to be added to the project folder. And at any time you want, you can click on this folder icon here and it will take you to your project folder so that you can see what's actually in there and what the structure is. And you need to be very careful and aware about what files are in your project folder. You're always going to have a maxproj file, which, as I've mentioned, is like a table of contents for your projects. And then you have the actual patches and media files that make up your project that are not part of the maxproj file, but they're in the project folder. All right, so let's start with just, I'll copy and paste a basic world and camera situation here. And because I have another patch open on my computer, I'm going to make sure my world has a distinct name. And I'm going to instantiate my poly tilde with my_poly, and I'll make 20 instances. Turn my world on, and there's my 20 instances of my object. Also, as always, I'm going to change into a monospace font such as Monaco and increase my font size up to 14 so things are a little bit more readable. So right now, as you can see, whenever I target all of my instances and set them to a particular position, such as 000, and here, note, I'm using the right inlet because the right inlet, inlet 3, is connected to my phys.body. All the instances are moved to the same location, and since they're physics objects, they can't be in the same location, so immediately they are pushed apart from each other. And that's because we can't set them all to different locations. Or we could, but it would be very cumbersome. We could, for instance, say target 1, position 000, target 2, position 100, target 3, position 001, and this will work. And if we use a button, we can trigger all three. And you know, you should know that this is a totally valid approach to send. I'll make this to -100 to send messages to all the individual instances and put objects where you want. That's totally valid. It's going to create a lot of message boxes and a lot of patch cords. And in the beginning with Max, that's what you have. You have screens with a lot of messages and a lot of patch cords. But as we move on, we're going to work on other strategies that involve fewer message boxes and fewer patch cords and do things more efficiently. And that's the space we're going to move into today. In order to do that, I need to show you a whole new structure. Which is the JIT.matrix. And the JIT.matrix is a spreadsheet of values inside of Mac. So if you've ever used Microsoft Excel, you can think of JIT.matrix as a spreadsheet full of numbers, and we'll look at that in a minute. We're actually not going to interact today really with the JIT.matrix object, but we're going to look at an object that creates a matrix full of values, JIT.noise. This creates a matrix full of values. You can think of it as a spreadsheet full of values that are random. It fills up the spreadsheet with random values between 0 and 1. Since we have 20 objects here, and the first thing we're going to do is change their color, and color has 3 dimensions, red, green, and blue. We're going to say for every cell in our matrix, we want 3 values to be stored. One for red, one for green, and one for blue. So our first argument is 3, JIT.noise space 3. Then we need the type of data that's going to be stored in each cell. And the type that we're going to work with is called a float, F-L-O-A-T, lowercase, no space 32, float 32. A float 32 is a 32-bit floating point number. This is a very standard type of number between 0 and 1 that computers use, a float 32. You'll see this a lot. This is not just a Max thing. You'll see this all across a wide range of different pieces of multimedia software, the float 32 data type. And then because we have 20 instances that we want to color, I'm going to create 20 cells in my matrix. So JIT.noise 3 float 32 20. And when I send a button, and here's a new use of the button. When I connect a button and click it, it's going to generate a matrix or a spreadsheet filled with 60 random numbers, 20 groups of 3 numbers, and each group of 3 numbers represents a color. And here's an easy way to visualize that. The JIT.pWindow object. JIT.pWindow, when you click away from it, it's going to become a window. It's going to become a screen, a patcher window. So watch what happens if I connect my JIT.noise to that, click my button, I get 20 random colors. That's very pretty. I'm going to put a comment here. This is a JIT.p window. And you should always be commenting your own patches. Take your notes in your patches so that the notes are always available to you and you don't have to be flipping through another notebook or something to find the notes that you've taken. They're right in the patch, right next to your work. So when I say this is a spreadsheet, I mean that quite literally. So there's an object that allows us to see inside of the spreadsheet, and that is JIT.cellBlock. JIT.cellBlock, when I create it, literally becomes an Excel-style spreadsheet in my Max patch. And the reason for this is because we want to be able to see the values that are being generated by the JIT.noise, or see the values that are in the matrix, not just as an image, but also as numbers. So we need to do a little bit of work here to get things into a format where we can view them nicely. We're going to use the JIT.transpose object, JIT.transpose. I'm going to take this and insert it. And take a look at what I do here. I hold down the Shift key, move it over a patch cord, let go, and it will insert an object into any patch cord. Same thing if I hold down the Shift key, click and drag, I can remove any object from a patch cord. You don't have to do it that way. That's just a convenience. You can also certainly connect it in line. So we're going to transpose our information so that it stacks up like this, because that'll make it easier to read in the JIT.cellBlock. And this is still a JIT.p window, and this is a JIT.cellBlock. We're going to send a couple messages to our JIT.cellBlock so we can see all 3 of the values that are in each cell. So we're going to send the plain message with the argument -1, so plain -1, and then col width. We're going to make our columns wider. We'll do col width, col width 200 pixels, and we're going to send that message. And now we can see all 3 of our values, all 20 rows of information. I'll move this up so we can actually see all 20 rows of information. And these are the 20 random colors generated by the JIT.noise. So we can put these two next to each other and size them the same. And you can see that each of these stripes in the window corresponds to a random color. So this dark red is 0.45 red, 0.11 green, 0.07 blue. This pink here is 0.9 red, 0.0 green, 0.94 blue. Lots of red, no green, lots of blue. And this is also a nice way to continue your understanding of RGB colors. When you see a color that you like, you can be like, oh, wow, that's a great color. I like this light pink here, 0.85, 0.58, 0.65. And you can stick that in the message box to save it for later if you want. 0.85, 0.58, 0.65. And as we know, the message box understands the color message. So anytime you do something like this, if you make it the color 0.85, 0.58, 0.65 message and send that message to a message box, it will color the message box in that color. So it's a little way to save colors that you like for later. So how do we take these colors and apply them to our 20 objects? We've generated 20 random colors. Every time we click the button here, we're going to generate a different set of 20 random colors, and we want to put them onto our poly tilde. Well, the first thing we're going to do is pass them through the JIT.matrix object. We don't really need to do that at this point, but by passing it through the JIT.matrix object, we're enabled to save it and also to resend it without getting a new set of random values. So if I click this button again, I'm going to get a different set of random values. But if I click this button, it will continually resend the same set of random values that are stored in the JIT.matrix. So that's a useful thing. So you just want to get in the habit of inserting a JIT.matrix after your JIT.noise. And actually, we don't want this JIT.matrix to pass through the JIT.transpose. We're only using that transpose for display purposes. Here, we're going to send the output of our noise into a JIT.matrix. And in order to get it into our poly, we need to iterate it. We need to take this image or this spreadsheet, and you can think of it as both ways. I mean, this is one of the nice things that a piece of software like Max exposes you to, that an image essentially is a spreadsheet. An image is a place where a bunch of numbers are stored. We're seeing these as colors right now. They could be positions, they could be scales, they could be impulses, they could be anything. So to iterate it, we use the JIT.iter object. And here I'm just going to highlight all the new objects we're learning right here and just give them a little color coding. Right, where JIT.noise is new, JIT.transpose is new, JIT.cellblock and JIT.pwindow are also new. JIT.matrix is new, and JIT.iter is new. JIT.iter takes every cell of our matrix and sends it out as a message and as a number. Now here I'm using the right inlet of message box so that the message box becomes a display tool. So when I click this, it sends out a number corresponding to each cell in the matrix and the values that are stored in that cell. So you see right now it's showing me cell number 19 with the values 0.19, 0.64, 0.31, and we'll see that corresponds to the last cell here, 0.19, 0.65, 0.32. It's 0.319, but it's showing up here as 0.32. What JIT.iter did is it took the incoming matrix and very quickly spit out all 20 cells and all 3 values stored at each cell. So we only see the last one, but it sent out all 20 very quickly. So the nice thing we can do right here is say target $1 and hook that right up to our poly tilde, so that as each row comes out, it's going to target that instance in the poly tilde. Now, there's one problem with that. What was the last number we saw? The last number we saw was cell number 19. But we're creating 20 cells. That immediately tells us that this JIT.iter, and in fact, the whole matrix structure, is zero-based numbering, meaning the first one isn't number 1. The first one is number 0. The last one is number 19. So what we need to insert in here is our first little piece of math, which is pretty much the simplest math you can get, +1. I'm holding down the Shift key to insert this into my patch cord. Why am I doing a +1 here? Well, because when jit.iter is talking about the first cell, this green cell, it's talking about cell number 0. But in polytilde, we know that target 0 has a special meaning. Target 0 means target all our spheres. We don't want them all to turn green. We want the first one to turn green. So when the 0th cell is output from the jit.iter, we want the first ball to turn green. So we just add 1, and that solves our problem. And you're going to find this, again, this is not a Max thing. This is a very, very common computing thing. Some things are 0-based, some things are 1-based. We're going to see, like, for instance, later we're going to learn the Uzi object. And the Uzi object sends out a rapid stream of button presses. And it numbers those button presses starting at index number 1. The first press is press number 1. And that's just a different, it's 1-based and not 0-based. And within any piece of software, within any language, you just need to know whether something is 0-based or 1-based. And if you need to convert between them, as we do here, a little +1 will typically do the trick. +1 will convert between a 0-based and a 1-based system. Poly is a 1-based system, and jit.iter is a 0-based system. So the next thing we need to do here is take these 3 values, and again, I'll use the right inlet of message box to display them. So take these 3 values and change them into color. There's 2 ways that we can do this. I'm going to show you both. We've seen $1 before. Since we have 3 values here, red, green, and blue, we can use $1, $2, and $3. So we can say color, $1, $2, $3. That means take the 3 values coming out of the jit.iter and make them the red, green, and blue values sent to the jit.gl.gridshape at the specified target. And that's going to, you see here, that's going to color in all of the spheres. And every time I send it a new set of random values, it's going to color them accordingly. And we can see these colors here match the colors here. Sometimes people are confused by the $1, $2, $3 initially. Eventually you will need to understand it. Feel free to also use the prepend object, prepend color. Prepend color does exactly the same thing. It puts the word color in front of the 3 numbers. And we're going to see that we have exactly the same thing. So prepend color in an object box, or color $1, $2, $3 in a message box are identical. In this particular case, these are the same. And again, I'm using that right inlet of the message box to display what's coming out of the prepend color. If I use the left inlet of the message box, the color of my message box will actually be changed. It's changed 20 times very rapidly, ending on this last color. But that's not what I'm trying to do here. I can actually do both. I can change the color of the message box and the values inside it, but it's the right inlet that changes the values inside of a message box. And that's actually also a very quick way to gather up color information. You don't need all these extra numbers here. Won't be able to see the difference if you just knock it down to 2 decimal places. So that's fun. We can change the color, get 20 random colors for all of our spheres. But that's just the beginning. Because even though these appear as colors and they create colors, under the hood, inside the cell block, we can see they're just numbers. And because they're just numbers, they can control anything. So let's map them to something else. And what I'm going to do right now, just to make space, I'm going to take this whole structure and I'll just encapsulate it. See, this is, and for those of you who are still struggling with the notion of encapsulation, this is why we use encapsulation. We use encapsulation to make extra screen space and hide stuff that we don't need to be looking at right this minute. So when I encapsulate that, I'll call it spreadsheet. I just stick it in there. So it's there. If I want to get it back, it's all in here. It's still working. Got my color information, got my values. Everything's happy, but I just don't need to look at it. It doesn't need to take up screen landscape right now. I'm going to get rid of this button for right now because we don't need it. Compact this up here, and I'm going to take this whole structure and duplicate it. I'm holding down Option, clicking and dragging. Option, click and drag. So all I need to do to have the random numbers generated by this jit.noise correspond to position is change prepend color to prepend position. And now I have a randomizer for color here, get a new set of colors, and a randomizer for position here that randomizes my starting position of my spheres. And I am going to turn off gravity with send fizz gravity 000, and send fizz is always sent to the jit.world, send fizz gravity 000, and now when I set position, these are all set to random positions. But what's the problem here? Oh, and before we get into that, note that I sent position to the rightmost inlet of the polytilde because inlet 3 is connected to the fizz.body, and that's where we set position when our objects are physical objects. So the problem here is that, yes, I'm creating random starting positions for the spheres, but they're all between 0 and 1, and my spheres are quite large. My spheres are 1 meter each, so they're still bumping into each other, which is the problem we'd like to avoid. We'd like to be able to space these spheres out so they don't bump into each other as soon as they're created. So what we need to do is we need to take our jit.noise and those values that we can see are between 0 and 1 and spread them out further. And the way we do that is by doing a little bit more math, right? Because if we have values coming out of jit.noise, random values 0 to 1, I'll say 0 to 1, random values to 0 to 1, and I want to spread them out, say, over 5 meters, I need to multiply these random values by 5, and then they'll be spread out across 5 meters instead of across 1 meter. Or I can even spread them out over 10 meters. I better increase my world box scale if I'm going to do that. So I'll do a send fizz world box underscore scale 10 meters on a side. And I'll send that. And if I want these to send as soon as I turn on my patch, I can connect my toggle here to a button and use that button to press both of these message boxes. And in fact, in this particular case, because I don't have any $1 arguments, I can connect my toggle directly up to these message boxes, and it's a little bit less messy. But if you're not clear on why that would work in this particular case, put the button in. There's no harm in putting the button in. Put a button in there so that as soon as I turn on my world, gravity is set to 0 and the world box scale is set to 10 meters on a side. But I still have the same problem here. I'm creating the spheres too close together. So now we introduce yet another new object, which is jit.gen. And jit.gen is like the patcher and is like the poly in that it has something inside of it. Jit.gen, I'm going to insert it here into my signal path between the jit.noise and the jit.matrix. Jit.gen allows me to do mathematical operations on the entire spreadsheet all at once. It's a very, very useful, very powerful object that we're going to use for the rest of the semester. We're going to use it very simply today. Perform math on whole matrix. And so go into the jit.gen, and we see by default it just adds input 1 and input 2. We don't need input 2 at all right now, so we can delete it. And we're just going to multiply, which is Shift 8, or the asterisk, multiply our matrix by 5. And we can also do the same thing here. We can go into Monaco 14 point, and we can bring things closer together so it's nice and clear what's happening. So we're taking the entire spreadsheet, the entire matrix coming in, and multiplying everything in that matrix by 5 and sending it back out. And we can see that this sort of solves our problem, right? Our spheres are created in such a way that they don't collide with each other as much. They each have their own location that they go to when they're loaded, but they're all up here in the upper right-hand corner of the screen. Why is that? That's not what we want. Well, let's take our P spreadsheet and de-encapsulate it here. Command-Shift-D. I'm going to get rid of my jit.p window because once I'm multiplying by 5, these are no longer colors. I mean, there's still colors over here because I haven't done any math on the color information. But the positions are now in the range of 0 to 5. And so we can't view them as colors anymore. They're not going to make sense as colors because colors are between the range of 0 and 1. We're now generating positions. And if we can see, if we hook this up after our jit.gen, we'll see much larger values. X of 2.5, Y of 4.1, Z of 0.38. Right, so we're dealing with, instead of values between 0 and 1 that are being generated here, we're spreading them out over 5 meters. And if we go into our jit.gen, we can spread them out over 10 meters, for instance. And now our random numbers are much more spread out. But they're still clustered in the right-hand corner. Why is that? Because they're all positive values. So they're all positive X, positive Y, and positive Z values. But we know that the center of our world is 0, 0, 0. Right? So since the center of our world is 0, 0, 0, positive values are all in the upper right quadrant. So what we need to do before we multiply is subtract. And this is called, and we're going to see this a lot, and again, this is not a Max thing, this is a very, very common concept in multimedia. Biasing and scaling. So we're going to bias our range of 0 to 1 so that it becomes a range of negative 0.5 to 0.5, so that it is a range that is around 0 rather than above 0. And we do that just by subtracting 0.5. Right? Subtracts 0.5 from every value in the spreadsheet. So a 0 becomes a negative 0.5. A 1 becomes a 0.5. So I'm going to add some notes. This is biasing. This is scaling. Multiply or divide. Now my random distribution is centered around 0. Every time I get a new random distribution, it's centered around 0. So this jit.gen is a very powerful way of performing math on a whole bunch of values to get them into the ranges that we want. And we can continue this idea. Let's get rid of that for the moment. I can continue this idea to deal with scale. And what I'm going to do is I'm actually going to change all of my objects to shape cube. And again, I can just change this prepend position to prepend scale. And just as a reminder, again, this is the same as the message scale $1, $2, $3. You can use prepend in an object box or scale in a message box interchangeably. And this goes into my right inlet of the poly tilde because it's going to the phys.body. And I can randomly scale my cubes. Now, I still have the jit.gen here, which is which is going to give me negative scales and extreme scales. I'm just going to delete it and take a look at what kind of scales I get if I just use the random values between 0 and 1. That's fun.